Well, we got our Mazda 3 back at Tech Garage, and we got a compressor noise. An AC compressor kind of rattles when we turn it on and off. So I'm doing a little preliminary diagnosis. I look down here, both of the fittings look pretty good. Everything seems to be intact. Take a glance down, actually see that the compressor's running. So you know we're gonna have to get this thing into Tech Garage today and do some further diagnosis on this AC system.
Now that's a rattle. That's exactly what the problem was. The car's owner told us he had a rattle when he turned the AC system on. So I've got the belt off, I've got the refrigerant recovered before I put it up on the lift. John, our Mazda 3 needs a compressor.
Yeah, it does. Welcome to Tech Garage, presented by rockauto.com. You know, that one was a dead giveaway, Brian, but a lot of these need a gauge reading, man. We always do that on Tech Garage.
Yeah, absolutely. And it was blowing cold air the whole time. Strange symptom, but the rattle bang was a clue that the clutch or something on that pulley was a problem.
Yeah, and this one's going to be an easy one for you. It's 4 bolts, going to be a piece of cake. You already got it recovered. We're good to go. But we have to understand a little bit about that AC gauge readings. I mean, we owe it to our viewers. You know, there's a high and a low side when it comes to the system. Take a look at this first graphic here. And this is important because the high and the low side is always divided by the compressor and the control valve. Brian, walk us through the high side.
Well, a little AC 101. It comes out of the compressor under high pressure through that condenser, through that entire route, through a dryer, all the way up to that control valve, and then there's a handoff.
There you go. Then what happens in the low side is where the compressor is actually pulling. It's pushing on the high side, pulling it in, up through the control valve, through the evaporator, and back to the compressor. So if you were to hook up your gauges, the low side would be on the blue side. That's why the pressures are low, because we're usually pulling on that side. The compressor's actually sucking it in. The other side is on the red side. That's pushing it out. So that makes all the difference in the world.
Absolutely. I got 4 10mm bolts, a few connections. This compressor is going to be off in no time.
You get to it. You know, we have to understand a little bit about pressure. So take a look at this graphic. You can see the first one right there, and we're running about 30 to 40 PSI on the low side. That's about normal. 150 to 250 on the high side. That's pretty good. Depending on the refrigerant and the temperatures outside, it could vary a little bit. If you go over to the right, well, you see the low side is actually running high pressure, and then the high side has high pressure as well. So if they're both high, that's usually something through the airflow or condenser causing it, or too much refrigerant in the system. Now on the bottom left over there, you see the low side's running low pressure, and the high side has low pressure as well. That's usually just an undercharged system. And the last one there on the right, well, the low side has high pressure, and the high side has low pressure. And what that means is actually the compressor's not pushing or pulling any of the refrigerant in. You're pretty much going to need a compressor. Now I have a couple compressors right here, and this is pretty cool too, because this one's called a variable displacement compressor, and I can actually demonstrate it for you in action. This is pretty cool. What makes it a variable displacement compressor? Well, check out these pistons inside. Now I'm going to move it. You're going to see the stroke of these pistons. Keep your eye on the stroke of these pistons right here, because what's going to happen is, although they're moving, they're not really moving very far. The stroke is not too much on there. So as I go around, now what I can do is, with the variable displacement compressor, I can come over here, bam, change the displacement. Now watch the stroke. So as I go around here, wow, we just changed the stroke. What does that do? Well, if we're changing the stroke, every time the refrigerant comes into the compressor, we're actually changing the pressures. We can do that electronically, or like this one with mechanical pressures and the use in the system of doing it. Now, what's going on with this car here is everything's fine. We're riding along. You can see it right here. I'm pushing the pulley, everything's good. But what happens is once I magnetically engage that clutch, you see that clutch pull in and out. Every time it pulls in and out, now that starts running the second one here. So that's running all the pistons inside. Now once we develop that load, well, that load starts making that pulley growl, and we're starting to get that noise. So once it's disengaged, spins really easy, bam, connect it, everything's pushing inside of the compressor starts working, and we're having a bearing failure. Well, Brian's moving right along with that bearing failure. He's about got the compressor off. Let's check in with him.
Well, it really is easy down here. There's the wiring harness out. You want to get this kind of up out of your way, and I got 3 of the 4 mounting bolts out. It's rarely this easy. So quick access. Let me break this guy loose. We're going to get this old compressor down out of here. Now you're going to see in just a moment what we're going to do after the break for really good quality service when you replace a compressor. Here's the old one. down and out. Wiring harness, everything protected. So take a look here. The refrigerant lines, see the O-rings right here? We're going to replace those O-rings. There's a whole story and process and procedure you got to follow with the right amount of PAG oil. We'll tell you more about that after the break. So stay with us on Tech Garage, brought to you by rockauto.com.
Tech Garage, presented by rockauto.com, is brought to you by Borla, the world's most winning exhaust. Custom Auto Sound, the originator of classic car OEM fit radio since 1977. And by rockauto.com, all the parts your car will ever need.
Welcome back to Tech Garage, presented by rockauto.com. Well, Brian, like always, my hands are nice and clean. Yours are dirty. Of course, you made short work of that compressor.
Absolutely. I tell you what, I wish they were all this easy. 4 10mm mounting bolts. Of course, we had a rock guard we got out of there. That guy came out very easily, but boy, you can sure hear the difference here.
Yeah, this one here, it's clunking, it's rattling. You can't feel it on TV, but trust me, it's grinding. This one here, rock solid, man, just like rockauto.com.
Absolutely. And I tell you what, I love this big fancy demo you got here, AC 101 and 202, but my friend, it all starts right here, so I'm going to get him installed.
Well, you get him installed, and I'll show you guys this big fancy demo. Our friends from Console Labs sent us an AC system. I could fire this thing up. This is a true running car. Everything you see on your air conditioned system's happening right here. And my friends, it all starts right here at the compressor. Now, the compressor is what Brian's replacing, and this is where it divides that high and that low side. So what's happening here is we'll go out the high side here with the high side gas. This is what's coming out here. Very, very hot. So if you felt your compressor on one side, it's hot, and the other side's cold, well, at least you know the compressor's working. It's pumping out here a high side gas. Then what it does, it comes out, and it goes over here to what's called a condenser. This is on the front of the car. This is where we're getting rid of that heat. And think about your bathroom mirror. You know, when you take a shower, it comes out steam, and then as it starts to cool down, it goes down there, it turns into a liquid. Well, that's what's happening here. The fans are blowing, that heat dissipation's happening, bam, it's going in a high pressure gas, and it's coming out an actual high pressure liquid. So it's coming in a gas, a liquid. Now, if you felt these two lines, one going in and one going out, it should have gave up some heat to the outside atmosphere. So you should feel a difference between these two, hot and maybe warm. And then what happens from there, it travels all the way over to this side. Now down here, this is our control device. Now, a lot of people have orifice tubes, and some have H-blocks or TXV, thermostatic expansion valves. But the whole key is here. We're changing pressures once again. We did it at the compressor, now we're doing it over here. So what's happening here is we're coming in a hot liquid, high pressure right here. This is red hot coming in, and then bam, we change that pressure. When we change that pressure, we get that temperature difference. So this is really cold, but now turns into a low pressure liquid. High pressure liquid, low pressure liquid. You can see it flowing through. Super, super hot, super, super cold. If it was hot on both sides, it's not working. So you can feel the difference. Then what it does, it travels up here to the evaporator. This is located inside your car. Your blower motor's blowing it over, and what's happening, the heat's jumping on the refrigerant, taking a ride back up to the condenser, bam, throwing it to the outside air. Thus you're getting air conditioning. So what's happening here is this cold liquid's coming in under low pressure, and then it boils off and it comes out a gas once again, low pressure gas. So from the evaporator, we go all the way back, pulls it back into the compressor, and starts that cycle over and over again. So just by feeling those lines, you can tell what's going on. But more importantly, Brian's actually replacing our compressor. Ours didn't have a pressure problem, didn't even have a temperature problem, but if that clutch started to fail or that bearing started to fail, you would probably see those pressures we saw earlier, where the low side would be high pressure because it's not pulling, and the high side would be a low pressure because it's not pushing. Good look at an AC cycle. You're only going to see this here on Tech Garage, but I'll tell you what, really cool cat. Brian's underway over there. Let's see how he's coming along.
All right, there's the second O-ring off. We'll come back to that in just a moment. So the next step is to go to John's desk and get a flower cup. He's got a bunch of these and it disturbs me, but the reason why is I took the old compressor and drained the available PAG oil out of it, spun it a few times to try to get it all out. It was about an ounce. So we took the new PAG oil bottle, put about an ounce into John's flower cup, and that's when I'm going to enter back into the new compressor. So do that gently, take your time, and as you pour it in, you want to turn the whole clutch assembly and kind of prime it right around there. Get it full. Get all that in it. It doesn't take too much. You're going to be surprised how little it takes. But you want to get that primed in there, right? And we're good, up out of the other side. So let me set that off to the side for just a minute. Now, the O-rings, critically important. You can do this whole repair, you skip the O-rings, you're going to have greater issues. Another good habit here for you is go clean your hands. I'm working with clean hands. Get the PAG oil. I've got the new O-rings that came with the kit. And I'm just going to massage them in between two fingers, get them lubed up, not only so they'll go on easier, but they're ultimately going to seal and protect it because the PAG oil has a lot of conditioner in it. All right, so let me start with the big one first. Come up in here, hold this, and you'll see it and feel it sit down in the groove. Now, the smaller one. Come up, come over, take your time, seat it down in. Want to make sure you're in that groove. I like to rotate it around, really get that oil spread. Now, we're ready. We're going to wipe this thing down where I made a mess. Now, ready to install this guy. So, there's the lines, there's the mounting bolts. I'm going to get this up, I'm going to get it torqued. And I'll tell you what, we're going to have some mighty cool riding around. Well, speaking of cool, we're doing the lower end assembly and the plastic gauge work on the LS engine. Stay with us on Tech Garage, presented by rockauto.com.
Welcome back to Tech Garage, presented by rockauto.com. Now we're making great progress with the LS lesson. Brian is coming along.
Absolutely, and once again, I'm ahead of you, John. I got all 4 of my pistons in. I'm torqued down on the bottom end. We'll go back and check that, but I'm ahead of you, buddy.
It's not supposed to be that way. Anyway, I got the last piston so you can see it anyway. This is pretty cool. First thing we had to do was stagger all the rings. You don't want the gap to go through there or you'll have blow by. It'll get through the cylinder, so we'll do that. Take our tool, Brian, if you help me stretch it on there like that.
Down over, yep.
That's perfect.
Give it a little tug.
There we go. Make sure your rings are tucked in there real nice.
Flat side of the bottom of the tool there.
There you go. Dot to the front here.
Dot to the front on the piston.
Dot to the front of the piston.
Everywhere else, you can see that.
Get the tool.
Sink her down
Squeeze
on there.
it down pretty good.
Get your
Those
Wheaties.
rings, yep.
There you go.
And then what I'm going to do is I'm going to send it down to you real carefully. If you had studs, you'd want to put some little rubber hoses on there so you don't scratch anything.
That's right.
Get it down, get it lined up. What I'm going to do is just simply tap the tool to make sure it's flush against the block. Bring the piston down a little bit. Come back, center the tool again. And then we should be able to give it a shot. You ready, Brian?
Sinker, buddy, sinker.
There it goes.
Well done.
All right.
Got the rag right down on the crank to protect that. Let's take a round.
Yep.
Look here.
Spin it around.
All right, ready?
Yep. There we go. Awesome.
Awesome. Tremendous.
Now we can go ahead and lose your rag.
Yep.
That's a good thing.
Get this rag out of here.
Pop the piston down in here.
Perfect. There we go.
Awesome. Now, Brian, if you work that piston up, I'll work the bearing. You got to go clear in, kind of push it up to me from the bottom, there. There you go.
Here we go. Got it. Yep.
Look at that. Wow.
Right down on
Beautiful. All right, you got the bearing.
Absolutely.
But before you...
Main cap here, really important. Numbers have to match numbers. You want that to go on right.
Okay, but before you do that, let's go ahead and do a little bit of plastic gauge, all right? This is pretty cool. Just another look at a measurement that's maybe not as precise as what we did by measuring the crank and then measuring the bore and subtracting the two, but this is pretty cool. I'm going to lay this little piece of plastic right on there. So if you look down there, there's this little piece of plastic called plastic gauge. Now we'll put the cap on. You want to do this dry. You want to make sure it's dry, and you don't want to spin the crank. So get your numbers right and get that on there.
Numbers right. You want to torque it down. And you're looking to crush that. Obviously, that's going to give us our tolerance and the acceptable spacing.
There you go. I'll run them down. You want to get the torque wrench?
Yep, absolutely.
Now what we'll do is we'll go ahead. The torque is 2 specifications. Is it what, 15?
15. Yep.
So you go down to 15 till you break the neck there. That's it. You got it?
Right there. Not much.
Yep.
Spin it. Accelerate here. There we go.
Perfect. And then the degrees. How many degrees is it?
80 or 81.
Okay, 80 degrees. So we're going to go around. Just look at your spec. Everyone varies a bit. I'm going to put this is called a torque angle gauge. This is pretty cool. And what I'll do is I'll set 0 here so you guys can see it. Let me get 0 over here. There's 0 right there. So if I bring this around to 0, I'll loosen this up. And what I'm doing is I'm actually got it on the bolt. 0's right there. When I pull it, I want to go degrees, a little more accurate than just the click type torque wrench. Yep. So I'll go around to all the way over to about 80 right there. Oh, that's scary, but it does it, all right? Yep, and we do the same thing on this one. Bring it back to 0, put it on there. And then what I'll do is I'll pull this one Once again, 80. Right about
Nice.
there, and that's
There you
nice
go.
and tight. So it's
Well
torque
done.
to specifications. We did the main bearings that way. Now what we can do real quickly is
Back
pull
it
this off. Brian, if you grab that cap real quick, grab that cap, and let's take a look straight off.
Coming straight off, you get a good look at this.
Nice. All
There you
right, see
go.
it's smooshed right there. So we're looking at about, I would say, almost 2,000s. Just check your spec, make sure it's right. If you have too much, you'll have oil leakage, it won't build pressure. You don't have enough, it's gonna seize up. Hey, you know what? We're going to the garage ed right after this break. Stick around, plenty more Tech Garage brought to you by rockauto.com.
Tech Garage, presented by RockAuto.com, is brought to you by Hunter Engineering, state-of-the-art wheel aligners and wheel alignment machines, steel rubber products, quality crafted rubber parts and weather stripping, and by RockAuto.com, all the parts your car will ever need.
Welcome back to Tech Garage, presented by rockauto.com. Now we made it through all the inputs on Garage Ed, so it's time to switch gears and talk about the outputs. And the first one we want to look at is a fuel injector. That's one of the biggest players out there. Now our fuel injectors are right here, and I can show them to you in action, which is really cool. You can actually see the injectors pulsing. It's with pulse width modulation. I come over here, I give it some gas, bam, fuel starts flowing even more. Now, how does that all work? Well, true Tech Garage fashion, we had to slice one right in half. Check this out. Look at this injector inside of here. This is pretty cool. You can actually see the wire windings on both sides that with the magnetic induction actually pulls up this pintle right here. I can actually pull the pintle out. That's the little guy in there that goes up and down to allow the fuel to either come through it or stop the fuel. If it's down, we're blocked. If it's pulled up, it's allowed to go through it. And with spring pressure, it's kept closed. A cutaway injector. How does it all work? Well, it's all about that pulse width modulation. And take a look at this graphic. You see the top one there? The injector is only on 5% of the time. That means that the computer's sensing, hey, it's a rich condition. The middle one, well, that's 50-50. Probably that 14.7, that stoichiometric number, he's pretty happy there. The bottom one, though, that's 90% on time. That would be a massively lean condition, and that computer's dumping fuel in. Now, these injectors, a couple of tests you can make, super simple. The first one I like to make is just take a stethoscope. These are inexpensive. I got this at rockauto.com. Come over here, come over to the actual sensor itself, and then what I'm going to do is put it on, and I'm going to fire it up. And when I fire it up, I'm going to listen for a minute here. So there it goes. Yep. See, I can hear it ticking. That doesn't mean the fuel's flowing through it, but at least it's ticking. I know I'm getting a signal to it. If I wasn't getting a signal to it, well, I can check it with a Noid light. Also got that set at rockauto.com. They got some cool tools there as well. I take that up there, take this Noid light, which is going to substitute the injector and not do any damage to the system. I'm going to fire it up. You can actually see it pulse. Well, what is that telling me? That's telling me the computer's working, the wire harness is working. I have a problem down in the injector. Now, those are some cool tests you can run, but you know what? There's even one more. Brian's checking it out.
Yes, and that test is for resistance. What we're checking is for the windings, essentially the copper inside every fuel injector, to make sure we have the proper amount of resistance so we have proper functionality. Every vehicle manufacturer has different specs. In this case, 13.5 to 17.5 ohms of resistance means we're good. We'll have to do that all the way around, but we're starting here. Now, you may not think the extra 10 or 15 minutes is worth it to make yourself up a little harness like this, but trust me, it's a game changer so you can get a good reading on everything. Uncle John made this one. He probably won't let me forget it, and I'll probably have to buy him lunch, but I'm glad he did. So we're pre-connected. I'm going to turn my multimeter to ohms of resistance, 13.5 to 17.5, and we're at 14.5. So this injector looks good. Now for more tech tips, Tom and John have some great information.
Well, we just took a good look at a fuel injector. Tom, that's kind of the heart of the system on the outputs, but it's part of a system, the key word being system.
Right, you need to look upstream and downstream to see if other parts are equally likely to be worn out or other parts might be failing and contributing to why that part failed. Something that's changed in the last decade or so is cars don't have separate fuel filters very often anymore. They'll just have a fuel strainer attached to the fuel pump assembly in the fuel tank. Some of them have more than one if the fuel tank is U-shaped. so that if that strainer's clogged up, it prevents flow of fuel to the fuel injector, and that can contribute to the death of the fuel injector.
Yeah, that's big amp draws. That's a problem. Fuel pump and everything, so sure.
Right. So something we try to do at rockauto.com is when we know parts need to be replaced together, we have come up with kits. The manufacturers come up with assemblies where they'll include everything that's likely to fail, but we come up with kits. Here's an example of a front-end kit that includes all the bushings, all the control arms and everything, so you're not mixing old parts and new parts. You don't want to put a new part on a worn-out part.
No doubt, yeah, and if you ever tried to push a bearing in or bushing in or one of these actual joints in there, you're going to wish you had the kit. Check them out online. Well, let's check in with Brian and finish up today's show.
The new compressor's in, everything's buttoned back up, and that new stretch belt is on. Final step, evacuate the system one more time, John, and get all that moisture out.
That's huge. At least 30 minutes, get all that out, and then we're going to recharge it, take it out, do a performance test. This thing will be better than new, Brian.
Yeah, absolutely. Tell you what, it's all about technology. I love the LS build today. The plastic gauge, precision is the key.
Yep, and Garage Ed, we looked at the auto air control, all that computer system, man. We're seeing how that all interacts with each other. You know, we're out of time for today, but keep the social media coming. We want to hear from you, but we'll be back here next week with more Tech Garage brought to you by rockauto.com.
Production assistance for Tech Garage is provided by Chipola College, located in Marianna, Florida. Founded in 1947, Chipola was ranked recently as one of the top 3 community colleges in the United States.